The learning goal for this lesson is to use slope to show that points are collinear. Use slope to show that points are collinear. In our first example, the following situation shows a plant growing. We've got a table of values here that shows weeks and the height of the plant after in inches after those weeks have elapsed. So what I want you to do is pause the video and complete these three problems. Compute the rate of change and then also the unit rate between weeks 0 and 12, weeks 4 and 10, and weeks 4 and 12. Compute the rate of change and also the unit rate. And so after a few minutes, I'll come back with you and show you my answers. So here are my answers. In the first case, we take 11 inches minus 2 inches over 12 weeks minus 0 weeks, and we get 9/12 inch per week, and that reduces to 3/4 of an inch per week. In the second one, we get 4.5 inches per 6 weeks, and to simplify this fraction, I'll double the 4.5 to get 9, and double the 6 to get 12, and that also reduces to 3/4. And part C, we see the same here. 6 over 8 reduces to 3/4 inch per week. Now, I want you to take the points that were in the table of values here and plot them on this graph. And in a couple minutes, I'll come back and show you what I got. So here's what I came up with. Here are the points plotted. And one main thing I want you to notice here is that if I put a ruler here and then connect the dots, I want you to notice that they all fall on the same line. So part E here, without calculating, what is the unit rate between weeks 0 and 10? So without calculating, what do you think the unit rate is between week 0 and week 10, and how do you know? So pause the video and discuss that with your neighbor for a couple minutes. So hopefully you guessed correctly that the unit rate between week 0 and week 10 is 3/4 inches per week as well, and that's because all the points fall on the same line. And one quick definition that we need to address here is that points are called collinear if they all fall on the same line. Points are collinear if they all fall on the same line. So these 4 points, we would call them collinear. So go ahead and pause the video and discuss what you learned from this example with your neighbor. In this next example, we have the following situation shows a plant shrinking. Again, we have a table of values for the input of weeks and the output of inches. What I want you to do is compute the rate of change and unit rate between week 0 and week 12, week 3 and week 9, and then between week 3 and week 12. You might want to check with a neighbor as well when you're finished. So go ahead and pause the video and we'll get back together in a couple minutes. So here's what I came up with between week 0 and week 12. It's a negative 2/3 inch per week. Between week 3 and week 9, negative 1/3 inch per week. And between week 3 and week 12, negative 2/3 inch per week. In part D here, we see the question, without graphing, which point is not collinear with the others? And how do you know? So a hint here is you want to take a look at the rates of change and unit rates that we computed in parts A, B, and C. So go ahead and discuss this with your neighbor, and we'll get back together after a few minutes. Go ahead and pause the video, and we'll get back after a few minutes and discuss it. So hopefully you found that the point 9,6 was the one that's going to be not collinear with the others, and that's because the rate of change or unit rate did not match with the others. So to confirm this, let's go ahead and plot the points, and just to make sure that the one point 9,6 does not match up or does not line up with the others. So here we see pretty clearly that the 3 points do line up or are collinear, and the point 9,6 does not line up with the other ones. I want to also take a look at something a little bit different. I want to draw in the path that we took from point to point. So for example, from week 0 to week 12, we moved horizontally 12. So 12 weeks increase there, and then the height of the plant dropped by 8 inches. And from week 3 to week 9, we went an increase of 6 weeks and a drop of 2 inches. And then finally from week 3 to week 12, maybe I'll draw it in a different, let's go this way. From here all the way to 12, that was an increase of 9 weeks, but then a decrease here of 6 inches. So a couple points to take away from this. In order to be collinear, all points must have the same unit rates or slopes. So in order for points to be collinear, they all must have matching unit rates, or in other words, matching slopes. And these red triangles that are drawn here are called slope triangles. They're formed by moving horizontally and vertically between 2 points. So go ahead and pause the video and discuss what you learned in this example. In this next example, the following situation shows a plant growing at a rate of 5/3 inches per week. Fill in the missing information so that all the points are collinear. So we've got a table of values here with a couple of missing values, and we're going to fill in those values. What I want to first start off with is the unit rate that they give us, which is 5/3 inch per week. And my goal is to find out the missing numbers. I'm going to start with this 24 here, and notice that to get from 9 weeks to 24 weeks, I need to add 15 weeks. So in my rate of change, I've got 15 weeks increase there. And what I want to find out is how much the plant grew, so plus what, question mark there, how much the plant grew in that 15 weeks. So I'll put a question mark there in terms of inches. Now this unit rate here, or so this rate of change here, should be equal to the unit rate if it was reduced. So what we can see here is to get from 3 to 15, we're going to need to multiply by 5, and likewise to get from 5 to that missing numerator there, we'll also multiply by 5, and so we find out that its increase was 25 inches over the 15 weeks. So now we know that we're adding adding 25 to the 16, and we get an answer of 41 inches there. So before we move on, go ahead and pause the video and discuss what we did in this part of the problem with your neighbor. So let's tackle this next one. And so we see here, we'll start off again with a unit rate of 5/3 inches per week. And we see that we're going to go from 6 inches to 16 inches. And so that would be an increase of 10 inches. So in our rate of change here, we're increasing by 10 inches. And we're not sure how much this is going to increase in terms of weeks. So we'll make it a question mark for now. So question mark in terms of weeks. Then we can see that to get from 5 to 10, we're going to double it or multiply by 2. Likewise, we'll multiply the denominator by 2, so 3 times 2 will give us 6 weeks. So now we know that it's going to be 10 inches per 6 weeks. And so now the question is, so we now know we're going to add 6 weeks there. So the question is, what number of weeks plus 6 will get us 9? Well, that is 3. So that completes the table of values, and because we made them all the same unit rate, we can be sure that all the points are collinear. So again, go ahead and pause the video and discuss what you learned from this example with your neighbor. In example 22, we have the following situation shows a plant shrinking at a rate of 2/7 inches per week. Fill in the missing information so that all the points are collinear. So again, we have a table of values with some values missing. This is one for you to try. So pause the video and work it on your own. If you want to work with your neighbor, but at least at the very end, check with your neighbor, and then I'll get back with you in a couple minutes and show you my answers. So here are my answers. I have for 0 weeks 19 inches, so the plant started off at that height, and at 35 weeks it reached a height of 9 inches. And just a quick summary of what I did, I noticed that from 0 to 14 that was an increase of 14 weeks, and so I took the unit rate, -2 inches per 7 weeks, and set it equal to question mark over 14 weeks. Notice that 7 times 2 equals 14. -2 times 2 gives me -4, so that would be -4 inches per 14 weeks. So what number minus 4 gives us 15? That would be 19. And so we can see that that's going to be a decrease there, since this is a shrinking plant. Next, from 15 inches to 9 inches is a decrease of 6 inches. Again, setting up this proportion, -2 over 7 inches per week equals -6 inches over some number of weeks. -2 times 3 equals -6. -7 times 3 gives us 21, so that becomes -6 inches per 21 weeks. So 14 plus 21 gives us 35. In this example, we have a sloped triangle with these measurements, and the task here is to decide which one or ones of the following sloped triangles could represent the same line. So you have a choice of A, B, C, D, E, and F. Now for this one, I just want you to discuss with your neighbor what you think the answers are, and after a few minutes, pause the video, and after a few minutes I'll come back and discuss it with you here. So let's see how you did. To approach this problem, I would suggest rewriting the triangles into unit rates, or you could say slopes. So this triangle, I'm going to start off with, since it's decreasing here, a loss of 3, and we'll call it inches over 7 weeks. And we're going to compare that unit rate with each of these triangles and their corresponding unit rates. So in this triangle, we see a loss of 9, we'll call it inches over 21 weeks, and that will reduce, if we divide both numerator and denominator by 3, that's going to reduce to -3 over 7 inches per week. So A does represent the same line, or same slope. Part B, this may have fooled you, but if we look at this, we're actually increasing 3, so that would be a positive 3 inches over 7 weeks. And clearly that's a different slope or situation completely than the given slope triangle, so that one's out. Part C, we have a loss of 13 inches over 17 weeks, and hopefully it's clear to you that that's not equal to -3/7, so that one's out. Here we have 6 and 14, so that's a loss of 6 inches over the course of 14 weeks. And that reduces, if you divide both numerator and denominator by 2, to -3/7 inch per week. So that does match up with the unit rate in the original triangle, so that one's good. 4.5 and 10.5. So If we write out here negative 4.5, that's a loss of 4.5 inches over 10.5 weeks. And maybe a little trick here is to double the numerator and denominator and get negative 9 over 21 inches per week. And that matches up with part A that we've already decided does work. So E is also correct. And for this one, we see a loss of 70 inches over the course of 30 weeks. And that reduces, if we divide both by 10, to negative 7 over 3 inches per week. Now, even though the numbers are the same, that's a different rate than negative 3/7. So part F is not the answer. So the three slope triangles that did match up and represent the same line would be A, D, and E. I want you to pause the video and discuss these results with your neighbor. As we end the lesson, I want to remind you that the learning goal for this lesson was to use slope to show that points are collinear. For a wrap-up, I want you to discuss these questions with a neighbor. What does it mean for points to be collinear? How can you tell that points are collinear from a table of values? How would you complete a table of values when given a rate of change? How can you tell if a set of slope triangles will form a line or describe the same line?